And hello from the campus of Carnegie Mellon University in Pittsburgh, Pennsylvania. We welcome you to the Software Engineering Institute's webinar series. Our presentation today is Context-Enabled Computing by Jeff Boleng and Marc Novakouski. Depending on your location, we wish you a good morning, a good afternoon, or good evening. My name is Shane McGraw. I'll be your moderator for today's presentation, and I'd like to thank you for attending. We want to make today as interactive as possible, so we will address questions throughout the presentation and again at the end of the presentation. You can submit your questions to our event staff at any time by using the Questions tab on your control panel. We will ask a few polling questions throughout the presentation as well, and they will appear as a pop-up window on your screen. The first polling question we'd like to ask is, how did you hear about today's event? Another 3 tabs I'd like to point out are the Files, Twitter, and Survey tabs. The Files tab has a PDF copy of the presentation slides there now, along with other context-enabled computing related work and resources from the SEI. For those of you using Twitter, be sure to follow @SEI News and use the hashtag SEI Webinar. Once again, follow @SEI News and the hashtag is SEI Webinar. And now I'd like to introduce our presenters for today. Jeff Boleng is a principal research scientist at the SEI. He joined the SEI in 2012 after 21 years of service as an active duty cyber operations officer in the U.S. Air Force. During his service, he was a member of the computer science faculty at the U.S. Air Force Academy for 8 years, where he was honored with the Outstanding Academy Educator and Computer Science Award for the academic year 2007-2008. Marc Novakouski is a member of the Advanced Mobile Systems Initiative and is a part of the Edge-Enabled Tactical Systems team at the SEI. His current work focuses on mobile systems at the edge, networking in disconnected, intermittent, and low bandwidth environments, context awareness, and advanced soldier situational awareness. Marc has over 15 years of professional software development experience, spanning the defense, commercial, and academic fields. Now I'd like to turn it over to Jeff Boleng. Jeff, Marc, welcome, all yours.
Thank you very much, Shane.
Thank you.
So today we're going to talk about a lot of the research and results we've been doing with context-enabled computing here at SEI. A brief overview. I'm going to give a little background about the group we work in the Advanced Mobile Systems group, and then sort of give some background and rationale for why we think context is certainly important, and where context, I think, is really a burgeoning interest for mobile and in the computing industry in general. Talk about some of the stuff we've done in the Advanced Mobile Systems group, and then we're going to go through a lot of use cases and experimentation that we've done to date, and hopefully that'll highlight a lot of the research and the results we've got. And we welcome your questions throughout. So Shane will field the questions, and we're going to dive right in. So the Advanced Mobile Systems group at AMS is about 12 people that do research specifically in technologies to aid dismounted soldiers and first responders that operate in edge environments. So we characterize edge environments by things that have limited computing resources, limited power, poor connectivity, and also high stress. So that focuses our research on things like being power aware and working well in low bandwidth environments, and also doing things to help reduce the stress that a soldier or a first responder might feel while working in an edge environment. So things like cognitive load become very important for a lot of the research that we're doing as well. Within the AMS Research Areas, we've got 2 big components. One is tactical analytics, and we can think of this as really the services and the application software that an edge user would use, either a soldier or a first responder would use. And then the other big area of research is tactical computing and communications, and we can think of that as the infrastructure piece to host the tactical analytic applications that run. So in the tactical computing and communications piece, it's much more about, we have a line of research called Cloudlets, where they're mobile clouds that can host a lot of the tactical analytics that we've got, and a lot of the routing work that we'll talk about today, context-enabled routing, falls under the tactical computing and communications. So in that piece, tactical computing and communications, we've got four big areas. The ones we're going to talk about today are information superiority to the edge. That's a context-aware mobile application, mobile situation awareness application that Marc's going to cover in depth. And then also delay-tolerant networking. We've done a lot of work once we get into these intermittently connected edge environments. Usually everything's wireless, wireless connectivity, especially tactical military radios. Sometimes work in challenged environments that are very intermittent and low bandwidth. So we've done a lot of work with delay-tolerant networking. We're going to talk about today about how we use context to increase the delivery and better utilize the bandwidth in those edge networks. And under tactical analytics, I'm going to briefly talk a bit about edge analytics because we used that in some experimentation to use environmental context, things like what's going on in social media, in order to help inform the behavior and actions of people in an edge environment, and then also about some fusion strategies, how we use context to do some data fusion strategies. So for Marc and I, a lot of the work we do, we believe that context is incredibly important. We are lucky enough to collaborate with a CMU professor, Dr. Anin Day. We call him the father of context computing. I don't think he's not always flattered by being the father of context computing, but I think he's younger than I am. But he authored one of the seminal papers back in 2001 about using context in computing. And so traditionally, when we talk about what context is, it's a lot of times it's a person at a location and a time doing something. And so that's one of the examples. The military example of that is cursor on target. It's a well-known XML schema that really is a very simple thing that's got a what, where, when for events that can happen in an edge environment. Our goal is to expand that. Marc's going to talk a lot more about how we expand that to make the context that we leverage a lot richer. And then there's a couple of definitions you'll see on your slides about how Dr. Day defined context, and we try to stick really true to that. So it's any information that's relevant to the task a user's doing at that time. And then also I want to make a distinction early on, because it'll come down later in the presentation, about personal versus environmental context. So from personal context, it's really a lot about what am I doing now, what data's on my phone that's about me that it can mine. And then environmental context are those things that definitely impact and influence me, but I don't have any control over. And so in a lot of cases, we want to try to fuse those two bits of context to help our systems deliver information more effectively, or save resources, or help reduce my cognitive load and make my decisions easier by presenting me the right information.
And to be clear, when we talk about environmental, we are talking about more, that word is a little bit overloaded. What we're talking about here is anything that is external that influences me. So that could be environmental, as in the weather, right? Because my plans will change depending on the weather. They almost did today. It was hard to get into work. Lovely Pittsburgh. But also, the environment in terms of the political mood, that's certainly going to influence what's been being talked about on social media. Also, the sort of tasking that the government might have funding for, right? So the government just put out an extra $1.3 billion, I think, in NASA's funding, right? So their context has completely changed, and they're trying to figure out how to deal with how they're going to do their tasking. So there's all sorts of environmental external contexts that influence me that may be worldview. It may have to do with people that I know. It may have to do with just the weather and the earth itself. And we're trying to find a way to bring all those together to better understand what you're doing and what kind of information you need.
Yeah, and so the popular press recently has started to come up with articles about context being the next great battle in mobile. And so if you look at the things that happen with Google Now, and over the last couple of years, as the Android operating system upgraded, I started realizing my Google Now cards are starting to shock me with the things that they know are upcoming for me. So, it tells me my flight's in a couple of days. Here's a restaurant you might want to try based on other things that I've done. That's all about how these agents are using my context to help me. Of course, Siri does a lot of that. Cortana now, with especially Windows 10, Cortana, and then the Amazon Echo is another good example. And then whatever the next device, the question marks on the slide is, whatever that next device is. So there's definitely a big battle going on of how can we effectively leverage context in order to gain market share, better assist users, and present information more effectively.
And one of the best situations is kind of considering the idea of the push versus the pull notification, right? So I need to know what my calendar has. I need to know what my set of tasks, I don't remember what it were from yesterday. So I pull up my calendar, let me know I have a meeting at 1, I have a meeting at 3, whatever it is. Google Now will now push to you, hey, look, it's pretty bad traffic. You should head home. I know that you usually try to go home at 4:45. You have dinner at 6 or whatever. You need a certain amount of time. Traffic's pretty bad today. And we have a couple of early adopters in our group because, Advanced Mobile Systems got a bunch of young guys in there trying to take advantage of the best technology. And they're just playing with this stuff and finding out, so it's starting to tell me stuff that I didn't know I needed to know, right? So getting understanding more than just what I know I need to know, but also ambient information around me that could affect me that I didn't even think of. So that's kind of the real barrier that we're trying to break into.
And bring those technologies to bear for first responders and dismounted soldiers specifically. Actually.
Exactly.
So polling question number 2, you'll see on your screen here now. We'd like to know, have you ever been surprised by one of your devices, mobile or otherwise, that it presented information or alerted you based on information it gathered from context? We'll take about 10 or 15 seconds to vote there. So I'm assuming you guys have had.
Oh, I've always been surprised, especially, like I said, a couple of years ago when Android started, with Google Now started really mining my emails more effectively and presenting stuff to me. And we had another member of our team, we were in California at an exercise, and another member of our team, how did that go with? Maybe we'll tell that story.
I'm not entirely sure.
It basically assumed he was someplace that he really didn't want to be, and started presenting a bunch of information. It was interesting.
We take a trip out to California, or at least we used to go to a government testing event. And while we were out there, it told him to go to this particular area, just in the area, and it ended up being something to do with Valentine's Day. It anticipated that he needed to meet this person, and we were like, that's really creepy. But hey, there's actually some thought behind that. But, the sort of things where it actually, without him even making travel arrangements for one of those trips, like some of us go sometimes, some of us go another time, it told him you need to leave now because traffic to the test location is, really bad.
So no surprise, 77% with yes, that they have been surprised.
Good.
Back to you, Jeff.
Yeah, I'm starting to think this is sort of a generational thing because I think people of my generation, I feel like I'm a little older than I want to be right now, but I'm surprised by the things technology are doing for me, but I'm certainly my 14-year-old daughter with her iPhone, she's just, never surprised at all. In fact, I think she's surprised when it doesn't tell her what she should be doing.
Exactly.
So I'm going to turn it over to Marc to talk about this information superiority to the edge, like I said, is a handheld digital situation awareness application that we developed as a research prototype to implement a lot of the ideas we've got about leveraging context. And so Marc's going to do a little bit of a deep dive there.
Right. So just kind of the elevator pitch for this line of work. What we kind of said in late 2010 is when we formed the Advanced Mobile Systems group, is that we were really concerned with getting the right information at the right time to people in these real high leverage situations. So somebody who's, out in the field, whether it's a soldier, in Afghanistan or wherever he happens to be or she happens to be, or if it's a first responder, the earthquake in Haiti a couple of years ago, the situation in Japan, something like that. So those people are in really challenged environments, and a lot of times they have a high information need, but limited ability to gather that information, to be aware of the information they need, and very limited ability to actually go ahead and get it because of connectivity issues, because of power issues, because of cognitive load issues. So we kind of tried to say is across the entire bandwidth of what Advanced Mobile System does is how do we address each one of those problems? And out of each one of those problems grew a different field of work. The information superiority to the edge piece of work, that task, was really about saying, okay, given that I am, for example, a soldier or first responder out in the field, what are my information needs and how do I make sure that I, A, can get that information, and B, not be overwhelmed by it? And really the key insight that we had with that particular piece of work was that the people in these high leverage situations are generally not working alone. You know, they work as part of a team, part of a group. And that identity within the group, both as the group as a whole, but also their role within that group, is a big driver to what their information needs are. And so if I'm a particular soldier, you know, I'm a medic on a squad, or you know, I'm the infrastructure guy who knows how to set up 4G Wi-Fi hotspots out on a first responder, then I have a specific role and I have specific tasks and I have an overall mission that my entire group is all participating in. So our work with respect to the information superiority to the edge task was to try to leverage the context of the group and be able to use that to push the information that they need to them when they need it, as well as filter out the information they don't. And that filtering piece, because they're very busy, you know, if you're dealing with a disaster situation, you're too busy to filter all the alerts on your mobile device. If you're being shot at in the field, you're clearly too busy to use your mobile device to try to figure out what's going on. That really kind of only the information you need is really focused upon what is your role within that particular task, within that particular group. And what we did is we started to build a system to not only understand the group context, but then to be able to process that and enable adaptive behavior via a custom rules engine that we built, so that we could take context cues from sensors, from external devices, and then use those to determine what the context information that an individual needs and pull that or push that to the necessary person. Next. So I'm going to go in a little bit on a deep dive. We have a lot of slides, so we're not going to get to all of them today. But just to give you kind of an overview of where we came from, the first thing that we had to do in order to make this work real was to try to build a context model that really kind of expands beyond just time and location, that who, what, where, when kind of thing. So, you know, if I pull up my my Android phone or my iPhone and I pull up the calendar app, it's what do I have on my schedule, where is it, and when is it? You know, that's true in the defense world. It's true in social media. It's true on my mobile device. But we need to be able to reason beyond that. And so we built, using the context toolkit that Dr. Day, that we talked about previously, we worked with him and vetted our model with him to try to expand that model out, to start to add in things like roles, tasks, group identities, different types of location, all those different elements. And then, you know, the interactions, actually, the relationships between my skills, the group that I'm part of, and then the tasks that I'm actually performing.
Yeah, I think one of the real keys to being able to do this is to have a rich enough data model to capture the semantics of the context that you've got. Right. And it's not a matter of having the perfect data model. Right. I mean, the best data model that covers everything. It's a matter of having a data model that's got sufficient richness in it that the semantics are easy to capture.
Right.
So I think as a first step was the data model.
Absolutely. And what we, you know, having worked in this field, we both knew that, you know, there's no data model that's ever perfect. We know that. There's no ontology that covers everything. There's no data model that'll ever allow us to process every different type data. That changes. But if we can generalize to the, you know, the very basic elements, then any kind of data that comes in externally, whether it's, you know, from this defense program, whether it's from the Red Cross, whether it's from DHS, we can bring that in and we can understand it as how it relates to the individual user. and then that can inform our model. And by generalizing and building this general model, and then building a general purpose rules engine that basically just uses various elements of Boolean logic, that allows us to react in arbitrary ways that change over the course of a mission. So that is the second part, which is to say, once we had that model up, building this general purpose context reasoning engine allowed us to start to react, to do different things, to push information, to pull information, to deal with different situations, to deal with different roles in different ways.
And it ends up being, I think the next slide might have it.
Mm-hmm.
No, it doesn't. But so it ends up being the fact that that rules engine is nice because sensor inputs, context of different levels, either very raw sensors or even high-level context can come in and trigger the rules engine to deliver information. Right. But also user actions and all previously delivered information can trigger the rules engine to then retask sensors.
Right.
So we get a really nice feedback loop throughout the whole thing.
Right. And the kind of the value of what we're trying to achieve, the two main things we're trying to talk about that we've discussed, but just to be very clear about this, resource usage. So, you know, I'm on the field, I only have so much battery, I only have so much bandwidth, it's going to be going in and out.
Limited compute power.
And limited compute power. So I need to be able to use all that information as smartly as I can. And if I don't have to burn cycles uploading or downloading or processing something that isn't important for me, that means I can operate at maximum effectiveness for much longer. So that means that overall the group is doing better, right? Better overall efficiency. That's what we're trying to engage there. And then the other thing, again, is if we're really busy with high leverage, safety critical, life critical situations, I can't have my cognitive state be shifted from this alert to that alert to all sorts of different things, what's happening on my Twitter feed, whatever it is, right? I need to be able to focus in on my task and only have the things that are relevant to my task or, you know, super critical things that I have to react to immediately because they override my current task be part of what I am being presented by my mobile device. That allows me to stay much more focused on my task. And we'll talk about a couple of experiments that we had where we're able to show that a little bit. Initial steps kind of a thing.
Yeah, so a simple example of resource optimization is something like the system understands that a group of individuals all have a shared mission and they're all going to the same destination at the same time. They're in a vehicle perhaps. One of the most power-hungry things we have on our mobile devices sometimes is our GPS. If we're all in the car together, why do we need our GPS, everybody's GPS turned on when we can just share location from one GPS to the others? Or better yet, we can scavenge the GPS from the car and then just share it to our devices and report things like blue force tracking and location for situational awareness and not burn all the resources of every phone.
Right. So the last thing we want to talk about with respect to ICE is that all of the different research areas that the AMS program, the team has kind of worked on, has focused on generalization. We want to be able to say, here is a general purpose solution for computing at the edge, for research scavenging at the edge, for analytics at the edge sort of thing. And in every case, what we've been able to do is we've been able to generalize and produce and publish a reference architecture for applications that would be able to handle these sorts of tasks. If you email the group, I'm sure we can provide you with some links to some of those papers if you have interest. But what we have on the slides right now is the general purpose reference architecture that is used and actually implemented in our ICE prototype. And then there are corollaries and companion reference architectures for the other fields that we can provide as well. Okay.
Well, I thought we had a polling question here. All right, so now we're going to dive into, I'm going to talk a little bit of a case study that we did around the consulate attack in Benghazi and talk about some group activity recognition that we did. Marc's going to talk about that. That was a fun thing to do. And then another event we experimented with cooperative versus opportunistic context sharing, which I'll describe more. And then at the end, we'll get into what we've done to use context for technical networks,
right? Moving
data through technical networks. So I think everybody in the audience is probably pretty aware of the event that happened. I think it was 2012 in at the consulate in Benghazi when the ambassador was killed. We had a request from some of our DoD stakeholders to do a what-if analysis and combine two of our tools. One of the tools that we used was the ICE prototype that we talked about, where if there were a bunch of people on the ground in Benghazi that day that had a mobile situational awareness tool that could leverage context and key and queue properly, combined with another system that we've got that basically takes streaming open source intelligence, so social media type data, and gives you a view of what is the sentiment or what are the breaking trends and stories in social media or in politics that while I'm operating with my handheld situational awareness tool. If we combine those two systems, what effect might that have had in a scenario like the Benghazi scenario? So essentially, we wanted to link open source intelligence gathering to mobile situational awareness cued by context. This is just a little quick overview, this slide of the Edge Analytics system. It's an architecture that scales very well for real-time streaming analysis of data. It's got a pluggable analysis engine. You can put a variety of analysis algorithms, plug it into the framework really easily, do things like we do geo-inferencing, which tries to locate a tweet that's not geographically tagged by the content of the tweet. It was originally focused on tweets. On Twitter, it's been expanded to do arbitrary text, and we're looking at other modalities like images, video, and voice. It'll do things like sentiment analysis, named entity recognition. It's got a whole bunch of those pluggable analysis engines. And so we wanted to couple that capability with the ICE capability that Marc talked about. So I'm going to give just a couple slides of background of the events that really happened then. This is all taken out of the Benghazi Senate report. We did a very close reading of that in a lot of the popular press of the day. So you know that between September 11th and 17th of 2012, as a result of the release of the web video, Innocence of Muslims, there were widespread protests in the Muslim community across the Middle East, Asia, and Europe. These things ended up that in Cairo, there was this demonstration of about 3,000 people outside the U.S. Embassy that then turned into a breach of the embassy wall and a tearing down of the American flag, and there were people injured there. And that happened about 5 p.m. on 11 September. And then later that night this is a depiction of the Cairo timeline. Well before the demonstration, several hours before the demonstration, we saw a lot of social media traffic asking for support of the demonstration or outside the embassy in Cairo. So it was one of those events that was planned by someone and definitely publicized on social media to get more people there. And then the attack comes down, and there's imagery on the slide there of them taking the American flag down in the embassy. And then after the demonstration, the fallout that happened after the demonstration. So that all trended on social media, and we used our social media, our Edge Analytics tool, to comb social media and find a lot of that information. And then later that evening, around 10 o'clock, is when the attack on the consulate in Benghazi happened. And so this is an actual image of that attack that then trended on social media within about 40 minutes of the attack. So that all is what happened. And then the next thing I go into will be sort of the case study that we did. So we have a polling question though, right? Quickly.
So you'll see that popping up on your screen now, polling question number 3. Can information valuable to law enforcement and defense be obtained by Twitter and social media? So I think we know the answer here.
I think so. Well, there are different answers, though. A lot of people say there's nothing but garbage out there.
Yeah, I was going to say, so that was going to be my exact question. So what about fake information? How do you guys handle it? Is that something you're going to cover later, or is that not something on the radar yet?
No, that is actually on the radar.
Yeah.
It's not a part of the context research we're doing, but there's another part of our group was funded this year, actually in 2015, one of their research focuses was coming up with automatic ways to deal with the veracity and the validity of the information in social media, because I mean, information operations is as old as human speech, right? We try to deceive our adversaries all the time.
The Trojan horse.
Absolutely, yeah, absolutely. And it's well known that there are a lot of information operations campaigns that occur in social media, and so we've done some implementation, mostly a bunch of research on how can we look at that information and cross-correlate across multiple sources to verify the validity of that source. And some of it comes down to, and I guess it is related to context, because some of it comes down to the source of the information. Who's sending it? Is it a wire service, or is it a random individual, or is it somebody that is maybe not a wire service but a well-known but respected blogger or social media person, and cross-correlating how many channels are we hearing this on, how many variations of the story are they, and trying to use algorithmic means. We're using machine learning heavily for this to say, is that now a valid piece? And it's never a yes/no answer. It's always we have with 70% certainty that this event had occurred or is occurring now.
And then the question is 70% good enough?
Right. Okay.
Yeah. Then you need the human back in the loop.
So to close the loop on the polling question, 100% yes.
All right.
We got an A. All right. So the next few slides that I'm going to talk about are it's a notional exploration of what would have happened if we'd had these systems available during that Benghazi attack. And we walked through. This is one of those things where we actually rehearsed the whole thing with the handhelds in our hand, using the system and saying, I'm over here doing this and I'm over here doing that. We even got to the point where we were using some real packet or mesh radios to move the data around. We wanted to be as realistic as we possibly could. Mm-hmm. So I'll try to go through this quickly because we have plenty more to talk about. So in preparation for this, you can go to Twitter and you can buy historical tweets, it turns out. We bought about a little over 1 million tweets from the 2-week period surrounding Benghazi and Cairo, with a whole several dozen keywords in them that matched the tweets. Those keywords occurred in those tweets. Again, geographically centered on Benghazi and Cairo. About 60% English and about 40% Arabic. So another offshoot of this research was that we had the Arabic tweets machine translated into English. It's not a perfect translation, but it turns out we use a lot of machine learning algorithms in this analysis, and machine learning algorithms kind of, for some purposes, are agnostic to how good the translation is. So we were able to effectively use those as training and analysis for our machine learning algorithms, even though they were machine language translated. So there's a lot of machines in the loop here, which is sort of interesting. Then, and then we integrated those 2 research prototypes. So the sort of an overview, we had 5 different actors in this script that we had. We had a business traveler. You could think of that as many business travelers. In fact, part of the discussion we had with our DoD stakeholder that wanted us to look at this was, what if we could give State Department personnel and business travelers, anybody that goes to a potential hotspot country, what if we could give them a mobile app that we could keep in touch with them and know where they are if something goes wrong, and then cue them and alert them in case they need to go do something. So we had a business traveler role. We had a consulate employee role. So somebody with a handheld was one of the consulate employees. We had some special operations personnel that may have been in the country on other missions, perhaps. The quick reaction forces were the one that was at the CIA annex, just southeast of the consulate compound. And then we had a command and control element that we were assuming could have been co-located at the CIA annex with the QRF, or could have been even out of the country. So the scenario begins in Benghazi with them monitoring the social media that's happening in Cairo. And remember, that happened 5 or 6 hours before the demonstration in Cairo happened 5 or 6 hours before the attack on the consulate. So that would have immediately, if they'd been monitoring those channels, they probably actually were monitoring CNN and stuff. I don't remember that date, how soon the Cairo events actually came out on the news, but that would have certainly, if they'd been monitoring social media, because there's no filter on social media, so it's raw, but it's fast, it's timely. They would have seen the demonstrations occurring in Cairo and said, maybe we should do something to up our security posture here in Benghazi. So in our scenario, about 6 o'clock, the data and imagery regarding the Cairo breach are shared with the Benghazi command and control element. And then at 9:40, the attack on the Benghazi mission, or the Benghazi annex, or the Benghazi consulate actually begins. And that's when things go into event. So what you see here is a couple of screen captures from our actual situation awareness tool. Excuse me. On the left, you'll see the view that the business traveler had, and they get an alert in their alert panel on the top upper right there. And what's happening here is each individual is just generating events and information on their handheld device specific to their role. And the system knows, the rules engine is set up to know which recipients are supposed to get which sets of alerts and which pieces of information, so that it's not a broadcast, everybody gets everything. It's very much tailored to the people that need to get it. So when an event like this, there was a rule in the rules engine that fired that said when aggression happens, we need to tell the business traveler to just leave. And so what happens when that event hits the business traveler's mobile device is it automatically generates routes to them to the bus station and the airport and the nearest public transportation to get out of the country. So that's what you see on the left panel there. The dark blue and the light blue routes, or those are automatically generated for the business traveler to be able to evacuate the country. And then that same event that was generated by the command and control element triggered the special operations forces to say, hey, we have a potential mission retasking for you. Do you want to respond to this? Do you want to stay on your current mission? Because it may be a very high priority mission. You want to stay on your current mission, or do you want to retask to support this the ongoing attack at the consulate compound? And if they say, yeah, I'm going to respond to the attack, it automatically generated the best route for them. And then there was some other elements of the scenario where there's actually a Predator video that was able to respond to this event in real life that noticed some blockades on some streets and some tire fires and stuff. And those routes can change in real time based upon if I'm en route and a blockade event happens, it will automatically reroute me around that blockade event, those kinds of things.
Right.
And those are all pieces of context that the system's able to do without anybody having to worry about, having to think through that. It's what you had to do was plan in advance and make sure the rules were there, so that when those information elements happened, the rules engine fired effectively. But during the heat of combat, when your cognitive load is really stressed, you don't have to think through that chain of events, and the system helps take that off you. We were talking about an Eisenhower quote on the way over here. I think it was Eisenhower, that plans are worthless, but planning is everything. And so this is the case where prior planning and having the rules in the rules engine is the essence of being able to have the system work properly.
Yeah, what the general purpose rules engine, the general purpose model allowed us to do is to specialize our response to a particular action in both the sending and the receiving side. So, if the consulate sends out an alert to everybody in Benghazi, the business traveler is able to get one alert. The special operations or the consulate employee will get a different alert. They got the exact same message, but depending on what their role is and what their needs are, they're going to get different instructions, right? So that's one end of it. Another end of it is to say, okay, here's a particular type of actions. I'm only going to send that out to, the people who are going to actually respond, the special operators, the quick reaction force, whatever it is. So you can tailor at multiple levels and have different types of responses. And in order to support that level of customization, to be able to understand those roles, you really need that context model that allows you to grok all those elements and how things work together, as well as the rules engine that allows you the flexibility to recombine things as you will.
So I hope that's a good illustration of of how we're using context in this context. I think I'm gonna move quickly through these next couple of slides so that we can get to more of this. The remainder of this scenario, a lot of this plays out where the quick reaction force responds and they're given better information so that they're more prepared as they respond to the attack at hand, which they didn't have at the time. In real life, they didn't have that, and there was some tragic events, and we lost some individuals in that response. So the rest of the scenarios, the details of the scenario are a little sensitive, so they're not included here. This was published in a Milcom paper in 2014, so I think there's a more thorough discussion of this particular scenario and the prototyping that we did in that Milcom paper.
And to be clear, we're not trying to say that our efforts would have necessarily made everything okay. What we're saying is that,
not at all.
Given a better understanding of context, we potentially could have done a better job of providing those people in those really high leverage situations a much better ability to respond appropriately.
And make better decisions. It's all about having the better information to make better decisions in a more timely fashion, so your decision loop is as tight as possible.
Right.
So some of the things we learned from Twitter, that our assessment is that in Cairo the demonstration was well planned, and there was, and in Benghazi it probably wasn't planned. The demonstration was well planned in Cairo, and the breach of the embassy was not planned. That was an outgrowth of just the crowd getting out of hand. In Benghazi, there was zero evidence of anything trending about a demonstration in Benghazi. It was all, nothing happened until about 22 minutes after the attack on the Benghazi consulate. Nothing occurred on social media until about 22 minutes after that attack began.
Right, and so the general idea here is to say, okay, if we have in a way to kind of mine this social media, this environmental context, can we learn about that, right? So we see in Cairo that there was, people talking about a demonstration. Then everybody got together with the demonstration. There were pictures, there were tweets, and then the demonstration got out of control, which we're all familiar. That's a thing that happens. And then, the event slowly died down and control was, regained. In Benghazi, we have a very different lesson, which is to say that out of nothing in terms of our social media, our environmental context, now we have a situation where everything got really violent really quickly.
Very quickly. Yeah.
And the evidence, looking back historically and going through the Senate report, shows that this is most likely a coordinated attack with people that had, weapons and were trying to cause damage and take lives. So if you are someone who is responsible for responding to that sort of event, then recognizing what's going on in this environmental context, recognizing that a demonstration might get out of control, but you're not going to be looking at loss of lives and a certain set of possible actors, or you're going to have a lot of innocent bystanders. You're going to have a very different response.
Yeah, just knowing that, the simple fact of just knowing I'm responding to a demonstration that got out of control versus I'm responding to a well-planned coordinated attack.
Yes.
It's a very different set of responses that I may have to have.
Right.
So we also found that you can use open source intelligence or environmental context for a variety of things. In this case, we showed an example of using it for forensic analysis. So we applied a bunch of data mining techniques to historical data to do a bunch of what-if analysis. You can also use it for reactive intelligence, which is a situation is emerging and I'm getting information that helps me react better, or possibly predictive or even preventative intelligence is where I can notice a trend occurring that's similar to other trends that have occurred, and I can do something to change the way that trend is occurring so that I can either lessen the damage or even prevent a bad outcome.
Right. So people have the right to demonstrate, and we're not going to be able to stop all demonstrations, but we can kind of look at the arc of demonstrations on social media and say, typically when this happens, then things start to get out of control. So if we can be aware of that when demonstrations happen, try to provide preventative measures to keep things from getting out of control, then, it is a better situation overall. Now, we're not saying that is a definite thing that exists, but we have the ability to look at the data and try to figure out if there are things we can do.
Yeah, so a few additional findings. We found out that machine language translation of foreign language is sufficient in a lot of cases. You don't get the fine points, but if you want to find the trends, it's good. Contextual delivery of information by role and task, which is what the ICE system that we talked about does, is very valuable. In fact, it can reduce clutter and cognitive load, facilitate information sharing and timeliness. It's really a nice thing to be able to have those rules built in a rules engine to know who gets what data when and to what degree they get it, how it gets prioritized. It even gets prioritized differently for different people. And then real-time analysis of streaming data. We did real-time analysis of streaming data after the fact, so we just restreamed it at the same rate. But one of the things is it's not necessarily appropriate to find a needle in the haystack. You can find the needle in the haystack after the fact with forensic analysis, but not probably during the event.
Right.
But definitely patterns and signatures of events do stand out. So as soon as something rises above the noise, even a little above the noise, that's where you can start to see those trends occur.
Right.
And then another thing that I think is obvious to most people is that sophisticated adversaries don't use social media to plan these events, but they may use them during the event for coordination. I think that was the case in Paris, actually, during the tragedy there, that they were using social media during the event. And then I do think that social media, Twitter is just an example, but social media in general, it can be very beneficial for public safety and defense. So,
okay, next polling question. We'll launch it now. Would a cloud-based context analysis engine coupled with personal context on a mobile device be beneficial in your problem sets or aid your mission? And while you're voting on that, we're going to take a question from Russell asking, what are the biggest barriers to leveraging context in an application or system? What are the biggest barriers to leveraging context?
Barriers. I have an
application.
Initial hit, then I'll let Marc answer too.
Sure.
I think one of the biggest barriers is context comes from everywhere. From sensors of different types, from raw sensors like inertial management units that is really high rate lots of data sensor that you have to distill to find out, oh, this means I'm shaking my hand. The data that's saying that is really hard to interpret. So the barrier, I think, is since the data comes from everywhere, it's all kinds of different formats. It's all different levels of semantic meaning. So normalizing all that data into some kind of a data model, I think, is crucial. So a big barrier is just the real heterogeneity of the data involved in really leveraging a lot of different context.
And I would definitely agree. I mean, the thing that allowed us to do the work that we're doing was to start with that context data model that was focused on the expanding the context toolkit. In addition, it's a matter of understanding that these are really complicated things. The decisions I make come from a lot of different areas that I wouldn't necessarily expect, that there may not even be a sensor for, right?
Think about now with the Internet of Things proliferation of sensors, we're going to have context data everywhere. We just are going to have to figure out what to do with it.
Right.
And my light bulb will tell me what the temperature is all the time. Why do I want to know?
And if the light bulb is, there was a thing I read about, light bulb burnt out, like but the thing was badly coded, and so it started spamming the Wi-Fi, and so the guy lost Wi-Fi, right? So those sorts of issues
Angry light bulb.
Exactly. Those sorts of issues are the challenge here, right? Bringing in all of the different feeds, normalizing, and then understanding how to recombine.
Yeah, putting the semantics really only come from all that data, all that context data, if you get them into a good data model, I think. So.
Yeah.
Okay, to close out our poll, 65% with yes, they would benefit from a cloud-based context.
Cool. 2/3.
Yeah.
And look, can we follow up with one more question from Scott?
Sure.
A little bit lengthy, but relevant to where we're at. So when you talk about getting business people out of the area in your scenario,
Sure.
how do you avoid clustering American citizens to create a new potential target of opportunity for those intending to do harm? Do you suggest routes and have them accept them so you know how many are taking each route? Relatedly, when you are tracking someone, there's always the potential to those intending to do the harm or intercepting the tracking. Does that limit the applicability of this to only to those with certain secure electronics to ensure these plans aren't being compromised?
Okay, so there's some layers to that one.
Yeah,
definitely. So
yeah.
First off, I want to say the level of prototype experimentation we did was not as detailed as saying, we're going to field this and we may have a whole bunch of different travelers, so we need to make sure that we don't cluster them and make them targets. So we didn't go to that scale. But I would say that's an excellent observation.
Sure.
And the rules need to be put in the rules engine, which the system's totally capable of, to make sure that if we have to do a mass evacuation of people from an emerging event like that, the rules can be actually coded so that it will send them to different places and it will balance their travel, and their locations are always constantly reported as well. So it can, in fact, try to make them as small a target as possible or keep them dispersed. So that's all possible. Right. Now the other part is more the security of the system, I think. The other layer there is, and we have to assume at least security, sort of industry best practice security that's as good as we get with our cell phones and stuff now. I think that, a lot of my services with Google or an iPhone services with Apple, a lot of those are not military grade secure, but I think they're secure so that we can sleep pretty well at night, that our privacy is being preserved, as well as the company that we decide to trust is preserving it, if that makes sense. Right. So I actually think the system can be useful without industrial grade or military grade crypto. Actually, our cell phones have military grade crypto. They use all the same algorithms. So I think that it can be effective as using industry best practice security. And if the adversary is sophisticated enough to be able to want to attack that piece of the security of the system to track the people that are evacuating, that's something we're going to have to we're going to have to develop countermeasures for, I guess.
Right. I would imagine there would, in a hypothetical situation that the State Department put out an app that did this sort of thing, not our app, because we're not trying to market this. This is just the prototype. But if the State Department did that, there would definitely be someone in the loop who would be doing the coordination and all those sorts of things. And the back and forth in terms of declustering or whatever is part of what could be possible if you had an understanding of who was doing what, where, and when.
Yeah, but I mean that's one of those things about planning is everything. That
Right.
coming up with that idea is a great observation. That
Absolutely.
you need to plan to make sure that doesn't happen.
Yeah.
Sure.
All right, so I'm going to turn it over to Mark. We wanted to expand from individual context, like am I walking, am I sitting, am I sleeping, what am I doing, based on IMU inertial management measurements, to if we have a whole group of people operating together, can we recognize what that group is doing? And so Mark's going to talk about some experiments we did with that we had a lot of fun.
We did, absolutely. So we tried to say, okay, so how can we kind of expand that context? What are the interesting things we can do? And one of the experiments we did with Dr. Day was he had a couple of students who were actually actively involved in doing activity recognition. And we said, well, could that be expanded to group activity recognition? And how would we even test that? So after doing a bunch of research and kind of saying, okay, so what we could do is we could take a bunch of people together, put a bunch of IMUs on them and say, all right, I'm going to put you in a situation where you guys need to move as a unit. Now, because, we work with a lot of military scenarios, we said, okay, we have this connection with the 9/11th Air Reserve Wing here in Pittsburgh. They're up by the airport. And we would get them all in, and we would say, go play some paintball and see what happens.
Well, the interesting thing is we actually went out and we were collaborating with the folks at the 9/11 to begin with, and we said, let's just do some walking scenarios and say, what if there were an IED here, an improvised explosive device here? How would you respond? And it turns out we put the inertial measurement units on them, and they responded certain ways, but they didn't respond with the level of conviction and urgency that they really would have.
Right.
And so we decided we needed a better feedback mechanism. And it turns out when you play paintball, when you get hit with a paintball, it really hurts.
Yeah.
So for small squad tactics, we wanted to see if we could do group activity recognition automatically of small squad tactics.
Right.
It turns out the feedback level that paintball gives you is enough that they behave realistically.
They really do. I mean, this is why we decided not to go with laser tag or anything like that.
There's no feedback loop.
Exactly. So we had a whole bunch of fun, and we allowed them to go out there and shoot themselves, and we determined that actually there is some viability here.
We have results here. Yeah.
One of the more interesting lines of research that we came up with. We have multiple gigabytes of video data that we took. It was definitely challenging to annotate it all. We had to go through saying this player is doing X, this player is doing Y. As a team, the group is doing this. And we're using, reservists, so they're actually using, relatively,
accurate squad tactics.
Accurate squad tactics. And so we could really get a sense for what each squad was trying to achieve in addition to what the individual was doing at the time. So now we're not the machine learning experts. We used the guys at CMU to really kind of get that knowledge. We used a number of different classifiers. A couple of details about what the best combination of sensors, because we had different sensors all over the body. We want to try to get a sense for what the best way to detect what your behavior was. But ultimately, we said, okay, for a particular type of classifier, machine learning classifier, given these sets of sensors, we actually came up with an 81% accuracy of individual activity recognition, and then on top of that, 71% accuracy of group activity recognition. Now, this is obviously initial results, but we did this over, a whole bunch of games, took a whole bunch of data.
Did 15 or 20 scenarios on the paintball field. Changing people's roles. And to be more clear, I guess, the individual activities we were looking for were things like shooting, taking cover, running, those kinds of things.
Yep.
And then as a group, was the group advancing together? Were they doing a covered advance where some of the people gave covering fire while the others advanced? Was I doing covering fire? So we were able to actually automatically recognize individual and group activity with pretty good confidence.
Yeah, I mean, obviously, this is very initial data. We're in the process of getting the data together, hopefully to do some publications on this.
It was a good excuse to, get my boss to pay for paintball too.
Exactly, that was a lot of fun. But yeah,
I think he's watching now.
The future of this, of course, is that if this is a real thing that we can leverage, then any kind of team-based activity where you have coordination, we can start to do training. We can start to do real-time returns in terms of what is the squad doing, and that's activity recognition. So if in the fog of combat, or you're in a very precarious situation in a catastrophe, earthquake or what have you, and everybody else decided to get out of Dodge and they just started running, and you just aren't aware of that, well, it'd be really good to get an alert to know that everybody's running. You better start doing that too.
Or at least consider running.
Yeah, exactly.
We don't want to be lemmings.
That's true. That's true.
So.
All right, we're going to launch another polling question. I'm going to turn it right back to you guys because I know you want to get through some slides, but the question will be up. Do you use machine learning in your research or operational systems? And I'll turn it back to you guys.
Okay. So we wanted to explore cooperative versus opportunistic context. So what we have in the case of ICE, the Information Superiority Edge prototype, is cooperative context. All of the devices in that mesh cooperatively share as much information as they need to be able to queue context for the group and better deliver information, retask sensors, all those things that we're doing, the rich set of things that we're doing. The devices all cooperate, and it's assumed that all of the people in the set of the mesh of devices all want to share the information to each other. There's another set of research that we've been collaborating with ANIND and somebody named Adrian DeFreitas, one of ANIND's researchers. They wanted to look at opportunistic context, because one of the things is hard. You hear about this wisdom of crowds, and it's great if we want to all share data, but how do you entice someone to share their context data? Because there's a lot of privacy associated with sharing my context data, and do I do it anonymously or do I not do it anonymously? So how can we create a framework that would share opportunistic context and then combine that with our framework that shares cooperative context? And we actually went out to it was the second or third year in Rome. We've been involved with this big Christian music festival in central Pennsylvania called Creation Fest. We go out there and we help basically provide, I don't know what it's called, intelligence support. We help provide support to the public safety director there of what's trending on social media using the Edge Analytics tool, so that he can have a good feel for the event or what may be occurring at the event. And so they allowed us to use that as sort of an experimentation venue to play around with this cooperative versus opportunistic context. So what we did is we created an application that was basically a reporting application for the volunteers. There are several hundred volunteers that support this 50 or 60,000 person multi-day music concert. And we gave them an application that allowed them to report things that might need, like this porta potty needs to be cleaned, or it needs toilet paper, or this garbage needs to be emptied, or there's a mess over here. And so they could report those kinds of events to the public safety director and the command center. And what we got from them running that application was all the sensors on their cell phone, all the context that their cell phone had. And we had the right disclaimers, and actually that was a bit of a challenge with the Institutional Review Board, making sure we had appropriate approval to use that app at this event. But we ran a bunch of scenarios, and we had some moderate successes and we had some epic failures, and this is still sort of a thing we're looking at, is how do we combine cooperative and opportunistic context, and how do we entice people to want to participate in a network where they share context so that they get at least as much as they give out of it.
One of the kind of scenarios that we're thinking about that would be really compelling for something from the standpoint of cooperative context is, like, let's say something happens at a mall, right? So there's an active shooter at one end of a mall, right? There's going to be a whole lot of noise, a whole lot of running, a whole lot of activity at one end of that mall. Maybe everything is normal at the other end of the mall because it hasn't propagated. When the police show up, it would be really useful for them to have a general sense for what's going on over the course of that whole building, so that they know where to go and where to deploy their forces, and at what point, to do a cutoff or something.
Right,
like
and
that.
where to evacuate first, and
exactly.
how to respond to that event, because it's a big building. I get lost when I go to the mall. I don't know which entrance to use. Every time, I'm serious.
Okay, before we launch the last polling question, I just wanted to wrap up the last one. It was a 50-50 split.
Oh, wow.
50% yes, 50% no. 7% in operational systems using machine learning, 23% in research only, and 20% in research and operational systems.
Interesting.
So we're going to launch the final polling question. Is how significant is the use of context to privacy? And we give some people a chance to vote there. We're going to work in a question here from Derek. And I know we're about a minute left here. It says, do you have any examples of context-enabled mobile computing with real-time info in snowstorms? If so, I'd like to know some stats such as system performance, cellular network usage, and latency.
Real-time info in snowstorms specifically?
Yeah, or just,
Right.
just his
The only
example.
thing that,
Yeah,
that
just-
occurs to me is the WEA system, the wireless emergency
Emergency
alerts,
alert, okay.
used to be known as CMAS.
But you can actually think of Waze, the traffic application Waze that
Sure.
is expanding beyond traffic, and the feedback, that traffic feedback you get from Google Maps and those kinds of things, I think is a similar, is in the vein of that question, I think, of that is being crowdsourced now.
Yeah. So we're here at 2:30 now. I'm going to give you guys the final word to wrap it up, and then we'll let the people vote for today.
The last big thing that we didn't talk about was applying context to routing, delay-tolerant networking, basically helping tactical military radios or just wireless tactical radios in general operate better. The slides are out there. We invite you to contact us. There's a lot more information. We actually have a limited distribution technical report on some testing we did with some 117 Golf radios, if anybody's familiar with those. And I think we have some great results there, so apologize for not getting to it.
Sure. As Jeff and Mark mentioned, the slides are available now in the Files tab on your consoles. You can walk away with them now. Any questions you have, feel free to send the info@sei.cmu.edu. Thanks for everyone in attendance today. Mark, Jeff, great presentation. Thank you very much. See you at the next one.